Welcome again to our EVSB Academic Channel podcast. And today we are very honored to have here with us Professor Dr. Zainuddin Sajuri on my right. As you can see, he's dressed resplendently in baju Melayu and a very beautiful Terengganu songket.
Yeah.
Yes.
Today is a special day.
Special day. What? Is it your birthday?
No. Today is Friday.
Today is Friday. Yes. Okay. Welcome to our academic channel, and we are very fortunate to have here an expert in very interesting subject in mechanical engineering, materials and mechanical engineering, which is failure analysis. All right. So if there anything at all that fails, and don't ever take my advice to the students. I always tell them what happens when you see something fail, and when they rack their brains, I just tell them run away as fast as possible. Then only you try and see what happens. So, but before we start, I would like to briefly introduce Prof. Zainuddin. Prof. Zainuddin is a professor at the Faculty of Engineering and Built Environment, specifically in the Department of Mechanical and Manufacturing Engineering. And his specialty is, when I first knew him, was actually in metallurgical engineering. But he has, he's a man of many talents. And I think as he progresses, he does a lot of consultancy and work in failure analysis, and I think forensic engineering. But the best person to tell about himself, particularly his academic journey, he has a very fascinating academic journey because he was the first graduate, to join from Japan. So I hand the floor to Prof. Zainuddin.
Thank you very much, Prof. Sna, for your kind introduction. Assalamualaikum warahmatullahi wabarakatuh. My name is Zainuddin Sajuri. I'm a lecturer at the Faculty of Engineering and Built Environment.
I said professor.
I got my professorship about 3 years ago. So I joined UKM in 2005.
Yes.
So this year is my 20th year.
Congratulations.
In UKM. Thank you.
A little bit about your background, where you came from, which state. I mean, that's going to be quite interesting.
Okay.
And where you went for your studies, and a little bit about, not just a little bit, even a lot about your PhD, and I think the topics and how you came to be in this situation. So again, to you, and as much as possible.
Yeah. Okay, thank you. I come from Selangor. I was born in 1971 at not small village, quite big village in Klang. But I think around 10 kilometers from Klang. So I got my...
The name of the village?
Kampung Bukit Kapar.
Kampung Bukit
Kapar.
Kapar,
Yeah.
okay.
Yeah. So I got my first...
your first
primary,
degree?
Yeah, primary.
Oh, you want to start with your primary
primary
education?
At Sekolah Kebangsaan Bukit Kapar. Then I continued my secondary at Sekolah Menengah Meru, and now the name changed to Sekolah Kebangsaan Sekolah Menengah Kebangsaan Meru.
Okay.
Then I got opportunity to further my study for my SPM at Sekolah Menengah Sains Teluk Intan. So after SPM, actually I don't want to talk a lot about my after SPM because some of the story was quite sad, but I got offered by GPA to study abroad, even though I thought during that time I was not qualified to study abroad. I just applied UPU, and then I chose local universities, but I don't know, somehow GPA offered me to go abroad, and then I offered by GPA to go to Japan. Before I went to Japan, I have maybe around 4 to 5 months Japanese language class.
Yes. In Malaysia or in Japan?
Malaysia, before I went to Japan. Just to get used to French,
know. At the Japanese embassy?
No, not at Japanese embassy, but it was conducted by GPA in collaboration with Japanese embassy in Kuala Lumpur. So the course, the Japanese course of training, was meant to give
an introduction
to Japanese language, to know the letters.
When you started, you didn't know a word of Japanese.
So that's why actually at the beginning, I'm also quite afraid to accept the offers because of the language
barrier.
Even English, I started learning English from standard 1 to form 5. I still cannot speak very good English. Neither British English nor American English. So now.
But you speak excellent Japanese.
Yeah, I speak broken Japanese English.
No, that's not. You have written a PhD thesis in Japanese.
Actually, my PhD thesis was written in English also, even though I took my PhD in Japan. So
in both languages?
Yeah, I wrote my technical papers in Japanese. Some was in English, but my thesis.
Your thesis, PhD thesis, was it like a regulation to submit it, or you had a choice?
Yeah, I had a choice to write it in English or in Japanese, but I choose to write in English because I have aim that after finishing my PhD,
you want to publish.
I want to publish, and I want to join Malaysian universities as a lecturer. So I thought that writing English would be more beneficial.
Okay. Now let us jump a little bit, and you're now in Japan. So what happens then?
Yeah.
You know why I'm asking all these questions is because I think he was one of the Prof. Zainuddin was one of our earlier candidate students to go to Japan. So this is a very interesting discovery of how a Malaysian, acquaints himself with the Japanese culture, and most importantly, the culture of studying. I think so. Over to you.
Okay, I went to Japan in 1991 for Japanese language. I went to Tokyo Institute language school, the language school at Tokyo for 1 year.
Were you alone, or were you with other friends? With a group of friends?
With a group of young Malaysian.
Also, young
Malaysian.
Young Malaysians.
I think around 80 to 100 students.
80 to 100, so you weren't very lonely.
Yeah. So for 1 year, I learned Japanese in Tokyo. Before I was accepted to join the diploma in mechanical engineering at the Ishikawa National College of Technology.
Where about is that?
That was in 1992. It's quite far from Tokyo, around 4 hours to 5 hours. During that time, there was no Shinkansen, no bullet train.
How shall I pronounce it?
Ishikawa.
All right.
Yes, Ishikawa. So I did my diploma in mechanical engineering for 3 years.
3 years.
Before further my study for the degree. So degree was in 1995 to 1997. So after finishing my diploma, straight away I continue for my degree in mechanical engineering
Yes.
at Nagaoka University of Technology.
So why did you choose Nagaoka?
Okay, in Japanese education system, they have a technical college. They have this technical college is very special because students who enter this college, they are come from lower secondary school, which means from Form 1 to Form 3. After finishing Form 3, they can choose to go to high school or they can choose to go to this technical college. If they go to technical college, they have to finish 5 years in technical college and get diploma. Okay, so after getting diploma, they can continue for for degree, or most of them, because in technical college basically they learn a lot about hands-on.
So it's almost like a TVET kind of education.
Yes, like a TVET education. So but student can choose to straight away go to
the academic path or
the
path,
or
hands-on TVET kind of education.
So I choose to further my study to bachelor degree, still under JPA. So JPA agreed to continue my scholarship from diploma to degree. So another 2 years. So
only 2 years.
Only 2 years.
At Nagaoka.
Yeah, at Nagaoka only 2 years for degree. So that is the specialty of technical college in Japan. They can transfer credit from diploma to degree. So they only continue for 2 years. I mean, we enter the university for degree, but straight away to the third year and fourth year, and we can get the degree.
So that was very good, like a shortcut.
Yes, shortcut.
And then you did your masters.
Yeah. Before I pursue my study in master, I came back to Malaysia, working for one Japanese company in Ulu Klang, and later came back to Shah Alam, where I stay with my parents in Klang. So I worked with Japanese company as a production engineer for 3 years.
That was a long time.
Yeah, but unfortunately during that time the economic situation in Malaysia was not very good, recession, and many employees were retrenched, and I got the opportunity, of course, to take they call it VSS, voluntary separation scheme. But of course, with 3 years experience in working, you can use that experience a lot to get another job during that very difficult situation.
It was not a sufficient leverage for you to get a good offer.
So fortunately, during that time, my supervisor in Japan, Professor Yoshiharu Muto, before I came back to Malaysia after finishing my degree, I said to Professor Muto, I want to continue for my master and PhD, but it is hard to get a scholarship for master and PhD. I tried to get scholarship from JPA, but JPA said no, we cannot give a scholarship for master and PhD student unless you are a government government staff,
or
so
attached to a institution of higher education.
So my supervisor, Professor Muto, advised me to go back to Malaysia and work for a few years. And then he said, I will call you back. So I think during my third year in the Japanese company in Shah Alam, I got a letter from my ex-supervisor offering me for a post as a master student in his lab.
Mm-hmm.
So I very
Sponsored.
He said, okay, sponsor. He said, if you come, I have
A grant.
a grant, and I can sponsor you to further your master degree here. So I'm really glad during the time, but unfortunately, the period of application for that scholarship was closed. So I changed my plan. I went to Japanese embassy and applied for Mombusho scholarship.
Yeah.
So Alhamdulillah,
You got it.
I got the scholarship. The scholarship is actually only for 2 years for the master degree.
Yeah. Okay.
So I cannot reject the offer from Mombusho, from Japanese Education Ministry. So I went to Japan again in 2000 for my master degree. So, but the first 6 months during that time, I was appointed as a research assistant in Professor Muto's lab. So not enrolled in the master program yet.
Yes.
So the first 6 months is only just
Doing research and assisting student.
So after 6 months only I enrolled to the master program. But my scholarship is only for 2 years. And master degree is 2 years.
Yes.
And I enrolled to master program 6 months later.
Yes.
So
you need
I have
6 months.
Yeah, I need another 6 months to finish my master degree. But before finishing my master degree, I said to my supervisor, I want to proceed to PhD. So he said, okay, I will think how to
get some
sponsorship for you. Okay, so he tried to shorten my master program period from 2 years to 1.5 years, so that if I finish within that 2 years, I can extend my scholarship, Mombusho scholarship, to another 3 years.
Yes.
Because the extension of scholarship is only once. Means after finishing 2 years, I can extend only one time.
Okay.
But if I finish my PhD, my master degree in 2 years, so I have to extend for another 6 months to get my master degree. So instead extending for 6 months, my supervisor advised me to extend for 3 years. So I have to finish my master degree early. So I have to defend my master thesis 2 times, because first is to convince the panel that I can finish my master degree in 1.5 years. Another thing is that to get the extension of scholarship.
Yes. So you passed both.
Yes, I passed both, Alhamdulillah.
Alhamdulillah. And then you started on your PhD. Can we have a little bit about what you did for your PhD?
Okay.
With this wonderful and kind supervisor, whom I know as well, actually, Professor Muto.
Yeah, Professor Muto is very kind person. He's very active in having a relationship with foreign student.
Yes.
So he linked Nagaoka University of Technology to many universities all around the world. I think all local university in Malaysia has a contact with him. I think in maybe after 2000 to about 2010, he has a very active relationship with all these universities, not only in Malaysia, in ASEAN, Indonesia,
ASEAN
Vietnam, Thailand, Cambodia, Myanmar, and some other third world countries in Africa and also in South America. So he's very active professor. So I know him. I knew him from my bachelor degree. So during my final year project, he was my supervisor. So I continue
for masters
and PhD also under his supervision.
Yes.
So in my master, I study about magnesium alloy, particularly the behavior under cyclic loading.
Okay.
Yeah. So the study was about magnesium alloy under several environmental conditions,
Okay.
high temperature, high humidity environment.
Under
that
extreme
was,
conditions.
Yeah, under extreme condition. I managed to publish a few journals during my master, so that I can proceed to my PhD. And my PhD also, I'm doing
Was on magnesium.
on magnesium alloy. So I
That
got,
was how I knew you.
yeah. So
Magnesium
5 years studies in master and PhD, all about magnesium alloy.
So you were studying a lot on magnesium, but rather than going deeply into this magnesium and magnesium alloys, I want to ask a more fundamental question. You know, you were completely, let us say, I think you were completely trained in Japan,
Yes.
and you came back and worked at UKM, all right? And you see many other colleagues who were trained elsewhere. So how does I should say, your Japanese background, Japanese educated background, impacted on the way that you teach and carry out research and interaction with colleagues at UKM? If you care to to share with us.
Okay, thank you. Actually, Japanese culture in teaching and giving training to students are quite maybe different from other maybe Western countries, UK, Germany. Maybe it's quite similar to Germany education system, where we are trained to do everything by ourselves. For example, starting from designing the specimen, machining the specimen, doing the testing. We operate our own machine, our own testing machine, even analysis, SEM, TEM, or other EVSD analysis. Also, we have to do it by our own. So so actually we really know the basic of doing research. Of course, they have a technician at the lab or machine shop, but they will teach only at the beginning, and they will let us do by our own.
By yourself.
Yes.
Yeah.
So that impact me a lot, because my professor said that, okay, Zainuddin, you have to master this, because when you go back to Malaysia, you will face the situation where you cannot get the facility as good as what you have it here in Japan. So you have to maybe to
improvise.
Maybe you have to fabricate your own testing machine, or you have to develop your own lab. So everything you have to start from scratch. Do not depend on other person to do it for you.
Yes.
So everything you have to do by your own. If you can do that by your own, you can teach your student, your technician to do it correctly.
Yes. So was there a big culture shock, if at all, when you first started your tenure at UKM?
Yes, actually, the system in UKM, especially at the Faculty of Engineering and Built Environment, here we do not have our own lab. In Japan, each professor has their own labs. Under one professor, there is maybe there are more than one associate professor or assistant professor, helping professor to supervise PhD, master, and undergraduate student.
So each lab is autonomous.
Yes.
Yeah. It's not like one research lab belongs to. Or is it just a research, or it's a lab that caters to both postgraduate and undergraduate?
Actually, it caters both,
both
undergraduate.
undergraduate.
Yeah, yes.
Okay.
So when I joined UKM, the system was different.
Very
Very
different, I should say.
There is no lab. One professor, of course, professor has enter lab, doing research, doing testing, but there is no such kind of this lab is under the name of Profusna lab and so on. No. So in Japan, so the lab is named under the professor's name, and then all students under his supervision will place in the same lab. So PhD, master, and undergraduate student will be in the same lab, and they can interact each other. They teach, and
there is a lot of consultation and
exactly.
help from the undergraduates. They can ask the postgraduates and so on and so forth.
Yeah, but in UKM, we have, for example, postgraduate research lab. Students all gather in one lab. It is also good because they can mix. But not undergraduate. Undergraduates is not.
There's some sort of separation between the postgraduates and
the undergraduate has no
access
or no specific place for them to be in the lab. So only the postgraduate student.
I see.
So that is the difference, and everything has to go through the lab technician.
Yes.
Okay, but in
there
Japan,
is more bureaucracy.
Yeah. In Japan, student is free to enter lab 24 hours.
Yes.
Okay. During my time in master and PhD, usually I enter lab around 7:30, 8 in the morning.
Yes.
So I can be in the lab until 10, 11 o'clock in the midnight. So and some students even they stay in the lab 24 hours. In the lab, professors give freedom for students. They can have a rest. There is a bed for them to rest. There is a place for them to cook, to eat. So the life, everything is in the lab.
It's centered around the lab.
Yeah.
Yes. So before I go into forensic engineering, okay, one last question about your, not one last question, one question before we go to your current work. Okay, I want to ask, because about your supervisor. Your supervisor, you said, Professor Muto, is somebody who believes keenly in like a mission of internationalization, right? He believes that we should, Japan perhaps, I feel that, I mean, knowing him, Japan like have a mission to educate as many people as possible from developing countries. And I know that in our work together, you have a lot of contact as well from countries not from just Japan or Western Europe or America, but around Asia and developing countries. So can you say a bit about that?
Okay, so after I came back and joined UKM, I feel that it is quite difficult to progress if I work, like a lone ranger, without any partner, without any collaborator. So of course I try to develop a connection with the industry, with the other people from other universities in Malaysia, as well as connect to people from outside Malaysia, like Indonesia, from Thailand. The person which I know them during my study in Japan, and also I started to collaborate with scientists and researchers from Iran, because in around the year 2010, 2011, I received my one student from Iran. He's very good and bright student, Dr. Amir Hussein Baghdadi. Currently, he is a researcher in Australia. So he introduced me to few researchers in Iran, and I think I also asked you about do you have any contact with the researchers in Iran? So you introduced me to one professor, Professor Amir Hussein Kokabi, from Sharif University of Technology.
Okay.
He is very good professors, even though he's quite calm and quiet, but he's very good publication referred and cited by many people. So the first scientists or researchers in Iran that I met is Professor Hussein Kokabi. So after that, I also visited many institutions, universities in Iran, where I met bright researchers,
many professors,
especially at the Amir Kabir University of Technology, and some other at University of Tehran.
Yes.
So I think this kind of collaboration, networking, is very good for us. Very fruitful, because we can have a joint supervision, we can have a joint publication, and it develop trust, because it is not easy for us or for them to have that kind of collaboration if we are not knowing each other. So I think until now I still have a collaboration with the researchers in Iran, and now I'm also going to Iraq, because two of my PhD students are from Iraq. They going back to Iraq and now become lecturers, and they also invite me to go to Iraq, and they really need our help actually in to progress in research, because their country has gone through very difficult time for many years, and now when they want to build again their countries, they need support and help from us. They are very good people, they are very good researchers, but they are lack of facilities, especially for equipment for analysis. So they can do their research, but they need some help from us to do, in order to publish their papers in very good journal, to do some analysis with a very good facilities.
So actually we have to, our mission is not just to teach in Malaysia, but we have a more embracing mission to teach everywhere in the world. The Ummah, you might say, that needs our help, and it's so urgent because they have gone through very difficult times, and they need our help, I think, urgently. And Alhamdulillah, you are there to help them.
I think now country like Afghanistan also, I think they are really need our help actually. At one time, I think early this year or maybe end of last year, some delegates from Afghanistan came to UKM and they asked for some help. But actually, the one is bureaucracy and diplomatic relationship between Afghanistan and Malaysia that hinder the progress.
Really good progress.
But they really need our help actually.
So inshallah, I think we must make dua that we can go over this hurdle of bureaucracy and diplomatic legalities and all that, and inshallah we academicians are able to do our part in helping not the ummah, just the ummah, Muslim ummah, but humanity in a bigger sense. So let us come back to
Okay.
Malaysia. Let us talk about your role as a forensics specialist and expert. You are very well known in that you are much consulted, I think, in the field of forensic analysis or failure analysis. And you are a consultant and trainer to Dodge, I think, and many other industries. So can you please elaborate about that, Prof. Zainuddin?
Okay.
And then after you elaborate on that, we want to hear some interesting stories, exciting stories of some of your consultancies.
My background is about fatigue and fracture. Of course, the subject during my master and PhD was magnesium alloy, but the knowledge of fracture mechanics, fatigue of metallic material can be applied to any kind of material.
That's right.
So when I came back to UKM, I started my research in fatigue and fracture, and I got my first FYP student. I still remember his name, Faiz Sudar. Faiz Sudar is my FYP student. After finishing the final year project, he graduated and joined KL Monorail.
Okay.
I think in maybe 2007, 2008, something like that. So during that time, KL Monorail was under SCOMI.
Yes,
If you still remember SCOMI.
I still remember SCOMI.
So one day, this Faiz called me, Doctor, can you measure the weight of monorail? I said, no, I cannot measure the weight of monorail. I don't have weighing scale that can measure that very big load. So I asked him a detail about what actually he want, what actually the problem that he faced in KL monorail. So when he explained to me, actually monorail run on one single track. Okay. So bogie is running on this track.
Okay.
And on top of this bogie, there is a passenger car. Actually, this passenger car is just sit on the bogie, and the bogie will run.
Yes. It's the bogie that's doing the locomotion.
Yes, exactly. So the problem is one plate placed on this bogie frequently fracture, break. So
and you don't know why.
And they don't know why. So the engineers thought that this may be because of the weight of the car is
Must
too
be the
heavy.
load, yeah.
Too heavy. So that the plate where the passenger car seat break. So okay.
They think it's the passenger car.
Yeah. So the thing is the weight of the passenger car is too heavy, and then the plate break, even though it is very hard and strong metal plate.
Yes.
So this I think started my journey in failure analysis. Okay. So when I got that request from KL Monorail, so I started my investigation, analysis, gather some evidence, and make some recommendation. Okay, what I found was actually not the load, not the weight
per se, not the weight per se,
not the weight per se, but it because monorail in KL it is not going straight, many curve and have to pass through buildings and so on. So when this monorail come through one curve, so one side of the car actually lifted. It's not attached to the plate.
I see.
Lifted, and then when it come back
it's
to
like
straight,
some sort of levitation.
yeah. So it a little bit lifted, and then when it's straight, it gives impact to the plate.
So it's impacting all the time.
Impacting all the time. So the engineers found that they have to replace this plate many times, and it costs a lot. okay, downtime, and then replacing the plate. So I
But
decided.
did you observe it actually?
Yes.
When you were observing it.
Yes.
You were actually observing that was how you were.
Yeah.
You
So
were able to come to the conclusion.
Yeah. How to measure the weight, the load, as what requested by KL monorail. So I have to place many strain gauges on the plate to measure the deformation at during static and during running. I have to work maybe during that time 2 to 3 o'clock in the morning to fix all the strain gauges, and then connect wires to computers to collect the data before the monorail run again early in the morning. When we collect the data, we know that at certain places some impact occur, and then when we bring back some sample to lab and investigate the strength, the tensile strength of the material, the hardness, the microstructure of material, then we know the material is very strong but brittle, very hard but brittle. So actually brittle is not good for impact. With few impacts it breaks. So we need very tough but strong material. So actually the problem occurred because the engineers during that time, they do not really think about this property of material. I mean, maybe they think that okay, very hard material is good.
It's good.
But actually it is not, because it is not tough. So in that case, they actually need a strong but tough material.
And you recommended?
Yeah. So my recommend during that time was to look back at the heat treatment of the plate, because the heat treatment was done wrongly, so that the material become very strong but brittle. Okay, so they have either to change the procedure of heat treatment.
Yeah.
Or
what did they choose?
I think they look back at the heat treatment procedure
and change it accordingly.
Yeah.
Okay. So you managed to solve.
Yes, I managed to solve that problem.
That was, I enjoyed that actually.
Yeah.
So tell us of another problem that you managed to solve.
Okay. I engaged with the Department of Occupational Safety and Health, DOSH.
Yes, DOSH.
Putrajaya. In DOSH Putrajaya, they also have one department called the Forensic Engineering Department. So I was first called to give a lecture on failure analysis. I think together with Prof. Ahmad Kamal Arifin during that time. So that was the first time I was introduced to many DOSH officers. And then after that, when some failure occurs, this department called me to investigate what happened. I got many cases of failure of tower crane. I think in early 2010 or maybe before that, because starting from 1998, where we host the Commonwealth Game. So after that, the construction what we call many high-rise building in Kuala Lumpur and Klang Valley. So construction company brought in many tower crane from China. Okay, but they are not bring in good tower crane from China. Some of the tower crane was a second-hand tower crane.
Yes.
And then
so it's not because they're from China per se. They just didn't bring very good quality ones.
Yes, not a good quality. China selling good quality tower crane, but they also selling if you
Interior ones.
if you
so it's your choice.
Yeah, it's your choice.
Yeah.
Okay, you have this much of money, you can get this kind of tower crane. So during that time, many incident of tower crane collapse. So Dosh came to me and asked me to investigate, and we found that some of the quality of the product was so bad, especially at the joint where they use a welding method to join steel to make the structures. If the welding condition is not good, this is prone to failure, accident. So I think I investigated.
Catastrophic.
Catastrophic. I investigated crane failure incident. I think more than 5 or 6.
That's quite a few.
Yeah.
That's quite a few. I mean, 5 is a lot.
Yeah,
I say quite a
Yeah.
few. Yeah, it's quite a lot. So, so before we talk about the last issue, which is your module, I hope you can share something about the latest, the most famous, I think, incident. I don't want to call it accident, about the explosion, the pipe explosion. I think that happened early this year, right?
Yes,
Are you
that
allowed
was.
to comment on that, or let us say, okay,
Nobody said to me that I cannot comment.
I
on
mean,
that, actually.
specifically your analysis and how your expertise can be brought into play here to advise.
As an academician, I think we are free to give our thought on some issues that related to our expertise.
Okay, I agree.
And that incident happened at the second day of Idul Fitri, I think. Second day of Idul Fitri.
Yes.
In the early morning.
Yes.
So
I was on the highway and I was able to see the flames. Yeah.
Okay. I was not involved in the investigation for that incident, but I was summoned by the police to give some statement as
expert opinion.
Yeah, as an expert in the field of failure analysis and fracture. And I give my sincere comment, opinion about that incident. In my opinion, because I didn't read. I think until now there is no complete report published by government or by DOSH about this incident. So I cannot comment a lot on that. Only based on the few slides that the government shared to us, telling about what actually happened during that day. So, in my opinion, because the pipe has been installed for more than 20 years, so during that time, the area there was no residential area close to
around
that,
the vicinity.
around the vicinity. So, and when development occurred in that area, the government built a road, building around the pipeline.
The pipeline
Okay,
itself.
and of course, people say the incident happened because of the maybe some activities using the heavy machinery close to that pipeline. But in my opinion, looking at the report published by government about the
were there a lot of structures available? Test results available?
No, not very much actually. Not very much.
So
but when
sometimes it's difficult to speculate when you don't have
it's difficult
much
to
data,
speculate.
right?
But when
But if you have extensive, experience, you can make a very good guess.
I think last year I I also doing some investigation on explosion of pipeline that occur in some
So
factories.
there could be some similarities that you can make a comparison.
But when I look at the incident in Putra Height, of course the pipe size is diameter is I think around 1 meter diameter, quite big pipe. But the fracture surface, the failure at the point where explosion occurred was really when we look at the picture, it's sharp. It is not like many not fractures like explosion. So it gives some indication that actually, of course, explosion occurred, but what happened before the explosion? Before the explosion, material cannot fail without any failure of the material itself. Okay,
it's not like a spontaneous failure. No,
it must started from very small atomic size. Okay, we learn in material science that the smaller defect in material is the atomic dislocation. That is the smallest defect that we can identify. But of course, we cannot see this by our naked eye. It is just theoretical, but it has been proven that is the mechanism of failure. But of course, we are not talking about that atomic level, that scale.
Not that scale. So we have to talk about a bigger scale.
Yeah, bigger scale. Why the explosion occur? Explosion can occur when gas leak. Okay, without the gas leaking, there's no gas at the surrounding. Why the pipe leak? In my opinion, from my experience about 20 to 25 years in failure analysis, there are some cracks that has been propagated, and the crack has become a true crack, maybe from the inner surface to the outer surface, but not the entire
it has
pipe.
Generated
at some area maybe it's already penetrate the thickness of the pipe. When the crack penetrate the thickness of the pipe, of course the gas can leak. But it's not causing explosion yet until the gas already saturated too much, and then some from some source, ignition, or maybe we do not know, maybe from kitchen, from some I don't know, fireworks, it caused the explosion. But as an engineer, when looking at this failure, we have to think about why the cracks happen. Okay, so if we look at the fracture surface of the pipe, it does not give any indication that
there was a crack and there was a leak.
There was an external loading given to that maybe sudden loading, for example, from the power shovel or the excavator that gives some damage to the pipe. So when we look at the fracture surface, I was told by the police that the fracture surface was very flat, and I also got some information from friends who are looking at that investigation, that the fracture surface was very flat. The flat fracture surface can be obtained through fatigue crack. Almost only fatigue crack that can give very flat surface, and it is like a radial crack. So
it's a classic case.
It's a classic case. When we see people who are doing failure investigation, fracture mechanics, when we saw flat fracture surface,
radial pattern,
almost we are confident almost 90% that this failure due to fatigue. So where come the source?
Does it happen?
How does it happen? It comes from the cyclic loading. Where the cyclic loading come from? So I think, yeah, because it is very close to road that crossing the pipeline.
It was acting like a bridge.
Like a bridge. So when the soil property is not maintained, the soil become very soft, and vibration can occur.
Yes,
When one side you are giving some load from maybe cars, lorries, heavy machineries that pass through the road, that give some loading, and actually that loading has been applied for maybe 10 years, 15 years or 20 years. It is not a sudden failure. The crack propagated for very, very long time because of the condition. Maybe at first during the development, the installation of the pipeline, it was not really designed for
for the multi-development that has taken place.
Yes. High-rise building, many residential areas and shops and so on.
Yes.
So I think that is the source of cyclic loading to the pipeline.
To the environment that has happened in the intervening years. When it was first designed, it was okay. But later on, when you have tremendous development and what it was subjected to, I think that caused it. Okay, that was very exciting, and I hope not too many people are upset by that. We all enjoyed that. So last but not least, we want to talk about your two modules. So the first module is mechanical testing of metallic materials, and I think what we are trying to get is people who are engineers in oil and gas, mostly, who has to deal with metals, but they're not metallurgical engineers. And the other one is your favorite topic, which is forensic failures. Are we finding faults or are we providing solutions? So before we break off, you please tell us briefly about these two courses.
Okay. I'm open my lab, mechanical testing lab in UKM to everybody, researchers, students, and also industries to come to do testing of their product, of their material. I'm offering machine that can do tensile testing, creep testing at high temperature up to 1000 degrees C. Also, we can do bending, we can do impact, we can do hardness test. So
the whole gamut.
The whole we can do fatigue testing. So I open also this lab for some training. So we are offering training about mechanical testing because it is very important for us to understand the mechanical behavior of material before we use the material in our application. Otherwise, it might end up in some failure because we do not know really the behavior of the material. So you can come to our lab in UKM, and we are now collaborating with Entrust, doing some training, and use some of our facility in UKM to give very deep insight and understanding about material behavior. Yes,
materials behavior, but particularly metals.
Particularly metal,
yes.
But we are not limited to metal
metals
only. Of course,
a whole range of materials. But because the course is for metallic testing, but maybe I want to paraphrase what Prof. Zainuddin says is we want to be able to use materials efficiently. That is, we are able to know how they behave and not only become concerned after they have failed and after a dramatic failure. No, we want to avoid that. So I'm afraid we have to come to a stop. We have had a very exciting time. So please, whoever is interested, you've had a very generous offer from Professor Zainuddin. Welcome to the lab. Welcome to our training modules, and whoever is interested in joining the training module, please get in touch with us at Entrance Ventures. So again, thank you very much, Prof. Zainuddin.
You're welcome.
You are very welcome for us to have another session. So, Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.